So this is the next question. I just also got from throw sheet. This is question number 4. Okay. So this one is actually very straightforward, right? Newton's Raphson method. So you see that Newton's Raphson method now, even this one is even better, okay, than what? The previous two. So we started from bisection. Bisection was quite slow. We looked at the fixed point iteration method. Okay, it was a bit faster. Okay, the convergence was a bit quick as compared to what? To the previous method, which is bisection method. Now, if you look at the Newton's Raphson method, it's even better. Okay, it's even better. So you can confirm from the previous question, you will find that, okay, we may even do just one iteration. You'll be able to find that 2.5 something with the initial condition given as 2.5. You can confirm that. Try it at your own time. Okay, the same equation that is given, not that one which is modified, but the actual equation, which is x squared plus x minus 20 equal to 0. Try Newton's Raphson method. I'm going to explain right now. Okay, so Newton's Raphson method. Okay, so we have the function. So find the real root of this. So the function. So Newton's Raphson method. This is the formula you people need to use. Okay, to find the root xn, you make use of the previous root, of course, just like it. Just like what? Just like the other methods work, right? Okay, so this is it over f of x n minus 1 divided by the derivative, okay, f prime over x n minus 1. So this is Newton's Raphson method. That's all. That's all. Okay. So this one, x of n, is actually the root you're trying to find. Okay. This is a previous root. Okay, of course, even this Newton's Raphson method relies on the initial condition. Okay. It also relies on the initial condition. So this one is when you substitute what? The previous value in the function f of x, and then also here you substitute the previous value in the derivative of what? F of x. That's it. So f prime of x, simply the derivative of the function given, and then you divide the two, right? The function, when you substitute the previous value, divide by its derivative, and then you have this, the previous value minus. So very, very straightforward, isn't it? Okay, so in our case, what is our function given? So the function given is this one here. So f of x is equal to 2 minus 4x plus cosine x. Of course, you need to make sure that this method works. F prime at xn minus 1 shouldn't be equal to 0. This condition is very important, right? The derivative of the function must not be equal to 0. Okay, so what I mean here is that if you notice here, this guy is in the denominator, right? So all the times you have a function in the denominator, make sure that that function must not be equal to 0. This condition is very important, right? Okay, so this method only works if the derivative of the function is not equal to 0, okay, at that point. And what point is it? Xn minus 1, right? At the point xn minus 1. This function must not be equal to 0. Because if you have a 0 here, then we are doomed, okay? We have something over 0 which is undefined. Okay, so this is just a condition I wanted to write. Okay, it's only valid if this derivative is not equal to 0. Okay, so now let's find the derivative first of the function. So f prime of x is equal to, so this is a constant, it goes to 0, this will be just negative 4. And then what's the derivative of the constant? That's negative sine x. Okay, so let's start substituting. So what I do myself, I do them separately. I'll just go back and substitute in the formula. So in our case, our x of n minus 1, it's more like our x naught when n is equal to 1, right? When n is equal to 1, our x of n minus 1, we're going to have x naught, right? So we're given the x naught, that's the starting value. So x naught is equal to what? What x naught are given in the question? 0.5, isn't it? Okay, so this is what we are starting with. So starting with 0.5. So now let's go ahead and substitute this guy in the what? In the function, because we need to substitute that guy in the function. and also substitute it in the derivative, and then we can come back and apply the formula. Okay, very straightforward, right? So what is the f of x naught or f of 0.5? Let's put in the function. Please, the person using a calculator, prepare it and make your calculator is in radian. The reason being is that we have a cosine, right? So every time we're dealing with a trigonometric functions, and it's in this course, your calculator must always be in radians. So what are you getting? 0.877 what?
58
58
25
25
61.
61. So it's very important to write the whole value, right? Okay, because remember, there's that issue of error. Very small change will have a very big effect. Okay, let's also substitute in the derivative f prime of x. This is going to go to 4 minus sine of the same thing. Okay, so sine of that guy is 0.877 whatever. Okay, so what are you getting here?
Minus 4.479
0.479
425
425
539.
539. Okay, so now we substitute those values now. So it means that we're going to use the values now to find the x1. Okay, so we are going to start now finding the solution x1. So x1 now, so for n equal to 1, remember that we're dealing with n equal to 1, right? So this now becomes x1. So x1 is equal to xn minus 1, which is the x naught, of course, the previous value for n equal to 1, which is 0.5. Okay, minus f of x n minus 1. Okay, so what is f of x minus 1, which is this guy here, right? Okay, which is 0.877 whatever there, and then divide by this guy, the derivative, right? Okay, which is negative. So notice that we are putting a negative and this negative here, so the end result, this guy will plus, because this one is bringing a negative there.
For f prime of x, I'm getting something different.
You're getting something different. Me, I'm just getting what you guys are feeding me with. What are you getting?
I'm getting negative 4.76.
Steve, are we supposed to use 0.5 or 0.887 on the,
Oh, I'm
on
so
the-
sorry. Yes, I need to use 0.5. I'm so sorry for that, okay? It's 0.5. Thank you so much. I was in a hurry. So use 0.5, okay? I'm so sorry for that. So you're going to use 0.5 in this f prime of
Then
x.
it's correct then.
The one that you
value.
found?
Yes.
Okay, so 4.7479 or 2, whatever there. So what do you get overall now? So make sure here you're putting all the values. I'm just cutting them. I'll just put all the values. What are you getting?
0.6959 14 084.
0.84. Okay, something like that. That's the x1. And then now,
so for the answer, is it absolute or you've just forgotten the negative?
Which negative here?
Mm.
I said, remember that here there was a minus, right? This minus here, and this guy also brings minus, make a positive.
Oh, okay,
yes.
okay.
Yeah. So let's now also get this value now, substitute in the what? So this will be f of x1, right? So this will be f of x1. We make use of this now. So repeat the same process. Okay, so what is the f of x1 will be? 2 minus 4 times this new, this is now a new answer found, right? Which is 0.6959, whatever there, and then plus cosine of the same, 0.6959. So what do you get there?
Minus 0.0161.
Minus
0.0161.
161.
88.
88.
311.
311. Okay. Our lady also should try to do something also in case maybe the guy made a mistake. Anyway, let's put in the derivative.
is correct. I also found the same.
Okay, let's also put the derivative. This is -4 minus sine of that. Okay, sine of 0.6959. Okay, you can finish there. So what are you getting here?
Minus 3.938.
Minus 3.938.
938. 15638.
15638. Okay. So now we found these two. Now let's go back and find x2 now. So meaning that x2 now, so this is our x2 you're finding, right? Equal to the previous value of x, which one? 0.6, whatever. Remember, we're using this formula. Don't forget. This is the formula we're using here. We're just depending on the previous value, right? Here. So xn minus 1 now becomes that x1, isn't it? Which is 0.69. Okay, sorry. 0.6959, whatever, 140 there. Minus, so now you see that we have f of xn minus 1. This is negative. Okay, it's negative. And also f prime of xn minus 1, it's also negative. So this negative and this negative become positive. So this main negative is to maintain, isn't it? Right? Is that correct?
Yes.
Yes.
Yes, that this negative is to maintain, since these two are already negative. Okay, 618.8311 divided by 3.938. So put everything here and then give me the new value. So the question says we have to do how many iterations? We have to do 4 decimal. So now we didn't check this up to 4 decimal places. There is a condition. So now since we have, let's now check this to 4 decimal places. So know what to do for decimal places, right? Okay, so first give me this value. So what value are you getting?
0.691.
0.6. Oh, sorry, why am I saying that? 0.691.
80.
80.
3368.
83.
33.
Oh, 3368. Okay. Okay, so the thing when you have to solve this to 2 decimal or to 4 decimal places, so we have to check that xn minus 1 divided by xn should be less or equal to 10 to the power negative 4. That is it. Decimal places to 4 decimal places. Those are 4 decimal places. So that person was confused decimal places. This is how we use it. Okay.
Yes.
This is how we use for the decimal places. If you are still confused up now, at least now you understand. So let's start with so since we are not aware about it, so we're going to start with the 0.5, right? And then we're going to use 0.5 and which one? 0.699, isn't it? So let's check those two first. In case we may never know what if they converged. Okay, so the present in this case for these two is 0.69. Could you please shout the whole value for me? 0.69 what? 59. In fact, it's here. Okay, 59140. Are there some values I've left? 82, right? Minus the previous was 0.5. That was the previous value. That was the initial value that was given to us. Divided by the same thing, 0.69591482. Okay, so what do you get here?
0.28.
0.28.
152.
0.28.
152.
Okay, it's okay. So this is already is greater than what? 0.00. In fact, 0.001, because this 10 power negative 4. Wow. Okay. So let's take the next one. Now it means now we're using this kind root. Which one is our kind root as x2? Is this one here. Let's see. So this is 0.69180 368 minus the previous. This now becomes our previous, which is 0.6959 140.82 divided by the present, of course, is 0.69180 3368. So what are you getting?
0.00595420226.
Okay, forget about the minus. Okay, this one. Okay, I may try to punch in case maybe. You
Yeah, I
never know.
found the answer as well.
Which one have you found?
You found 0.0059.
Yes.
Okay, because I was surprised. Look at this, the difference between this guy, 6969 should give you something, 0.00 something like.
I made the mistake. I used the upper one.
So that one we found. So give me the one that is ready just from finding the women. Okay, how much is that? Please, I need that.
0.00.
Sorry,
0.0059.
59.
42.
Okay, just end there because we just have to compare this. Still, but it's greater than the 0.001, right? So we need to move, at least we need to find another zero here. So let's do one more iteration. Let's see what you're going to get. So what will be the next iteration? So I can maybe just remove this. So let's do another iteration. So this will be x3. Okay, so we need to find x3. So before we do that, again, let's repeat the process. So f of x2, right? So we're going to use x2 equal to, okay, this is the 2 minus 4, right? Because we need to find this guy on top, right? That's what we are trying to get this, remember? This f of x n minus 1 first, right? And also its derivative. So 4 times 0.69180 3368. And then this, that a plus the next one, I think. Is that a plus? Yeah, plus cosine x. So plus cosine of 0.69180 33 whatever there. Okay, so what do you get here as f of x2? You tell me. And then also you have to find also the f prime of x2. So what is f prime of x2? It's -4 minus sine 0.69180 3368. So you get the answer there. Tell me. Okay, so others should be punching this one. Others should be punching this one, right?
First one I found 0.002883378.
0.0028.
Yes, 288 3378.
And then who tried the second one, the derivative?
Negative 4.63
Negative 4.63
79
79
26987
46
26987
987
26987.
2. Okay. All right. Okay, so that's what we get. And then now we can now go back and substitute. So we're going to have x3. So x3 now we go to the previous value, which is 0.69180 3368. And then there's a minus here. Now if you notice here, this f of x has is positive, or derivative is negative. So this negative and that positive will become negative, and with this negative way, the overall will be positive, not so. Have you seen that? This one is positive, This one is negative, right? So negative and this negative here, the overall will be positive, right? So I can just put that positive there. And then once you put positive, please don't put a sign again to this, right? Okay, but it just depends on how you want to do it. So if you want, you can put negative, maintain the negative, and then put the way the values are. It's fine, right? So 0.002883378, right? And then divide by 4.637926 987, something like that. So what do you get as x3?
0.6924.
0.69
242
2
50634.
50634, right? Okay, now let us check again this condition. Okay, so the present minus the previous divided by the present, right? Let's check. So remember the condition you're checking. So 0.692 now becomes the present. 42564 minus the previous now is 0.691803368 divided by the present value, 0.69242 5634. Okay, in absolute. So how much is that?
0.
Mm-hmm.
0 0
Mm-hmm.
0
0
Mm-hmm.
and then 89
89.
7
Okay, so still this
85.
this still gets 0.0001, right? So let's find one more now. Let's get one more. Let's get one more. I think now we're going to, the condition is going to be satisfied. Let's see. Again, repeat the process. F of x3 this time around. So this will be 2. So you see, this math is very simple, but just requires a lot of time. Like I've always said. Is there anything hard here? Huh?
Exhaustive.
Yes, that's the only thing that you get, this math. You just have to make sure that you're fast. What do you get as f of x3 and also get f prime of x3, which is -4 minus sine of 0.6924, whatever there. Yeah. Of course, this value we're putting is x3, right? Okay.
Yes, for the first one, minus 0.000000.
How many zeros?
Yes, 6 zeros.
That's now converging, right? 6 zeros.
Yes.
So one more zero here, like this.
147.
147.
Yes, 246, 147, yes.
Okay, that's now more like converging now. Okay, and then the second one, who's managed to get the second one? And dear people, if you have you noticed something? As this solution converges, f of x approaches 0. Have you seen that? This guy on top here, to check that it's converging, this guy on top has to be reducing. While this guy here in the denominator has to be increasing. So at overall, this fraction goes to 0. So just remain with this part. Have you seen? So all the time you're doing the iteration, this function here has to be reducing, going to 0, while the derivative has to be going to infinity, increasing. Okay? So that you are making this overall function almost equal to 0. Otherwise, if you find that, this f of x is increasing, this guy is reducing, or maybe anything that which is unusual from what I've said, then just know that there is a mistake, or it doesn't converge, it's diverging, because the value you are getting, maybe it's getting bigger and bigger and bigger and bigger. or smaller and smaller and smaller and smaller. Okay. So, tell me what do you find as, for the derivative?
4.638405,628.
Minus 4.63,
384?
another 3,
No, 6384
8, 4,
05
0, 5,
628.
6, 2, 8. Okay, so you notice that, yes, the derivative keeps on increasing. So I'm sure this time around, this is the last one we are finding. I think we've actually reached. Let's check, okay? So now let's substitute to get our x4. So this will be our x4. So x4, because now we are using x3, and x, remember that x is what? 0.6, 9, 2, 4, 2, 50, 6, 3, 4. Okay, minus, and you see this is minus, this is a minus, right? Those two are dividing, they become a plus, so it means this minus to maintain here, and then 0.0000006 zeros, 14746 divided by 4.638405,628. Okay. So yes, tell me what do you get now as x4?
0.692425,031.
0. What?
692425.
25
031.
031.
Mhm.
So you see, there is a convergence, right? Look at this. The values are not very much different, right? The previous and the present one. You see? Okay, they're not very much different. So now let's apply now the present value minus the previous value. So the present is what? It's almost, the difference between them is almost 0. So we've converged. Minus the previous 0.6924250 634 634. Please start subtracting fast here, and then divide by 0.692425025031. So what are you getting now?
It's 0.7 zeros.
0.7 zeros.
Mhm.
1, 2, 3, 4, 5, 6, 7.
4, 6,
So
7,
it's
9.
already, don't even waste time. This guy is very less than, it's less than what? 0.0001. Okay, so now what is our solution? So it means that our value of x is equal to this guy that gave us that, right? Which is 0.692425031. Okay, that is what we get. Any question, please? Any questions? So let's sketch this guy. So it was 2 minus what? So 2 minus what? 4x, right? Was it 4x plus
Yes, 4x
plus
plus
what?
cos x.
Cos
X.
Steven, can we just go to the actual question? I mean calculation.
Okay, actual question. Okay, I'm coming. Okay. You want to see the actual questions?
Yes, I want to confirm something on the calculation. The last step.
Okay. Here.
Okay, you can continue.
All right. So if you notice where it's crossing the x-axis, it's the point where this guy crosses the x-axis. Let me zoom in. Okay, so I think I reached the maximum. I reached the value of x. Anyway, it's just giving me to 2 decimal places. It's lazy.
Oh, yes, yes. That's 0.69.
Yeah, it only gave me 2 decimal places. Yeah.